tell me if you can see something.
So it should be coming. Yes, we can see it now.
Yes. Okay. Yeah, welcome to our short presentation. Our pilot is called Green Energy Management for Green Farms, and we have developed a tool called the Power Farms tool. Essentially, the problem setting was that for agricultural areas in the northeast of Austria, you have different kinds of energy demands, especially for irrigating the fields or cooling the harvested crops after the growing season. Especially the irrigation, which is done for the crops, consumes a lot of energy and is very expensive for the farmers. And the idea was to create a so-called energy community among the farmers so that they can produce, for example, renewable energy from photovoltaic plants locally, and also consume that energy for the irrigation of the farm. So it's essentially for the power which is needed for the pumps on the fields. The energy community model is something newly introduced in the European Union, and I think Austria is one of the leaders in implementation of this new regulation, which allows basically to produce and consume energy on a local area without having to pay, for example, grid fees. So grid fees are highly reduced, and this is why it's economically interesting. Yeah, so that was our pilot, our problem setting, and we have delivered a software tool which can plan such an energy community for agricultural areas and for farmers. And this is what I want to show you here. So here you see our project area. It's called Lassee, which is the region of Machfeld, quite a popular, famous region in Austria where we grow all our vegetables. And what we have done here in this project area is we have created objects for agricultural fields. So those are these green areas here. If I'm clicking on them, for example, I see some data of these fields. I see, for example, their total energy consumption per year. And when I click on other components here, for example, on these violet ones, I see buildings. And buildings have, for example, a roof area, and then that roof area, you can define a PV module. So you can basically plan different buildings here with different production capacities. And then you can define farmlands, as I've shown you here, these green components. Just going to change that map view because this allows you to see that also a little bit better. You see these green areas are those farm components. These violet ones are the building components, and then these gray ones are the cooling house components. So as I mentioned in the beginning, they also have a lot of energy demand for cooling of the crops, and we built actually also a model of showcasing how a cooling house might consume energy from this local energy community. So you can specify these components here in the energy planner tab. So you can create a new building, you can create a new field. In that field, you can specify the crop which is being irrigated. Here, for example, so here in this case we have a corn crop, 100%. So you can also have a corn 50% and then a carrot 50%, which would kind of add up 2 different crops for that field. And in the background, the different energy demand models are being created. So, for example, a corn might be irrigated in May, whereas the carrot might be irrigated in September. And this has a very, very important, so this knowledge of when and how this crop is irrigated has huge influence on the question of how much local energy can be used by this field during that energy community. So we can specify these components, and now I'm going to the most interesting part, the calculation. So all this data is being sent to the servers, and the energy market model is being simulated. So what does that mean? That means Here, for example, is an example for June. This is a week in June. And what you can see here on this diagram is the total production and the total consumption of electricity in this area. If I go to this total power consumption, I see the total demand. It lies about 2.5 megawatts in this case. I see also the total production of PV, and I see what is very important, that community energy, the area, this pink area, tells you how much energy these different agricultural fields and cooling houses and so on can consume from the local energy community. This amount of energy you don't have to buy anymore from the grid. This you really save because you produce it locally. Yeah, we can also look at different parts of this energy community. So as I mentioned, this is the let's say the total view, the total sum of everything. We can also look at different buildings. So for example, we can look at this Halle EG, for example. We see it doesn't have an energy demand in this area. What I will do is I will show you how that looks on a yearly basis, not just a week in June. So now, supposedly the results should be upcoming. Yes, so this is how it looks on a yearly simulation. You see a lot of peaks, but you see really from January to December the different consumption and production patterns, and those can be analyzed, and we know exactly how much PV, how much energy from the PV plants we can use, and how much energy of our total demand we can actually supply with the PV. So these are very, very important KPIs to increase the self-sufficiency of a local energy community. And maybe the last thing I want to show is how that looks like for different areas. So these are how apartments, for example, are being supplied. So we see during the summer period, there's a lot of pink. So it means there's a lot of local energy which is available for these buildings and apartments, whereas in the winter area, there's less pink. Yeah, it's logical because in winter, the PV produces, of course, much less energy than during the summer months. And very interesting is also how these irrigation fields look like. So this is now corn. Corn is being irrigated during the month of August. So we have those demand curves here, very high spikes because they are irrigated during the night with a very high power, and then during the day, nothing. So we have to consider that also. And this is what we do. And you can see corn is irrigated in this area, and we calculate how much of that irrigation of these fields can be done for the community. We can also look at asparagus, for example, is irrigated during July, or spinach, for example, is irrigated during April and May. So we consider all these different irrigation periods and then look at how much PV production is there and how much we can actually supply locally. The last thing I want to show you is the cooling house. This is how the cooling house looks like. Very interestingly, the cooling house consumes in winter and not in summer, which was a surprise to me because I expected cooling house to be in operation during the summer months. But in fact, this is kind of like a shock frosting technique. So they, after harvesting, they immediately cool it down and ship it off to the supermarkets. And because these crops are actually growing during the summer months, the cooling periods are really the autumn and the winter. So very interesting results, I think, which will help us understanding more on how we can create self-sufficiency for farmers, reduce their energy bills, and also increase their renewable energy share.